All right, in our theorems homework, I'm going to go over a few things that I think you might have some trouble with. On number 2, we need to find the zeros of f of x, and so we should remember from Algebra 2 and pre-calculus that to find the zeros, we want to think of the possible zeros. The possible zeros are the possible factors of this divided by this. So plus or minus 1, 2, 3, 6. And I usually start with 1. And if you notice, when you plug in 1, you get 1 minus 7 plus 6, and that's 0. So because f of 1 equals 0, and I just did that by checking, we know that x minus 1 must be one of the factors. So I'm going to end up with f of x equals x minus 1 times some other things, because when x is 1, it made it equal to 0. So we're going to do long division, or if you know synthetic division, you're welcome to use that. We're going to put 0x squareds here. We need a placeholder for that. X goes into x cubed. X squared times x squared times x minus 1 is x cubed. Ooh, this pen is a little bit rusty. And when we subtract, remember when we subtract here, that goes to 0. When we subtract here, subtracting a negative actually adds. And so we end up with x squared minus 7x. X goes into x squared, x times. And again, when we multiply, we get x squared minus x. And when we subtract, we get 6x, negative 6x plus 6. X goes into negative 6x, negative 6 times, and when we multiply, we get negative 6x minus plus 6, and that cancels out completely. So f of x equals x minus 1 times x squared plus x minus 6, and this is helpful because now we can factor this even more. So it's going to be x minus 1, as we knew it would be, times this factors into x plus 3 times x minus 2. I just factored the quadratic there. And now that we've done that, we have our zeros. The zeros are at x equals 1, negative 3, and 2. You might notice this was an AP question from 1989. There used to be a lot more things like this. There aren't as many now, where they test a lot of Algebra 2 stuff. Like, this is not a calculus question. This is just a pure Algebra 2 question, and it used to show up a lot on the AP exam. It shows up less often now, although these skills still need to be there. Write an equation to the tangent line. So we need a point. So when x is negative 1, we're going to plug in negative 1 and get 12. And we need the slope, so we need f prime of x is 3x squared minus 7. And so f prime of negative 1 is negative 4. And so our point is going to be, or our slope at negative 1 is negative 4. So our equation of our tangent line is y equals the slope times x minus x1 plus y1. We need to find the number c. This is finally into the theorem stuff we've just been learning on part C. And this is very accurate for what happens on the AP exam, is this usually just comes up in a part of a problem. There'll be another problem that doesn't have anything to do with theorems, and then they ask you a question very much like this. Find the number c that satisfies the conclusions on the mean value theorem on the interval from 1 to 3. So the mean value theorem says that the average slope between the beginning and the endpoints, which I'm going to find here, f of 1 we already found was 0, and f of 3 is 27 minus 21 plus 6, which is 12. The average slope between these points, so y2 minus y1 over x2 minus x1, has to occur somewhere. So the derivative, which was 3x squared, or so f prime of x was 3x squared minus 7. And so the derivative at c, there has to be some value of c, where that derivative equals 6. This is a quadratic equation, but notice there's no second c value, and so we can just isolate, get c by itself here. 3c squared equals 13. I just added 7 to both sides. Divide by 3. And so c equals plus or minus the square root of 13/3. Now, only one of these two solutions for the value of c where the slope is 6. These are both values, both plus positive square root of 13 thirds and negative square root of 13 thirds, are values that make the derivative equal to 6, which is the average value. But the mean value theorem says that this value of c has to be between 1 and 3. And so obviously the negative value we don't care about. The c value we care about is square root of 13 thirds, which is somewhere in between 1 and 3. And that's how we would leave our answer. Okay. I think I will let you guys do number 2 on your own. Number 4 I want to talk about. We want to see how many values of c between -4 and 4, how many values of c appear to satisfy the mean value theorem? Well, the mean value theorem says that the slope between the endpoints, so here are the endpoints, and the slope there is 0. The slope has to occur at some value of c. Now, it could occur at more than one value of c, and that's what this is asking you, is how many values of c will there be that have a slope of 0. And it happens right here, and right here. All of these have a tangent line where the instantaneous rate of change is 0, which is equal to the average rate of change between the beginning and end points. Is this an example of Rolle's theorem? Well, yeah, Rolle's theorem applies when the slope is 0, or when the end y value and the beginning y value are the same. The easiest way to say that is f of -4 equals f of 4. Those two y values are the same, and therefore Rolle's theorem will apply. All of these values are where the slope is 0. Let me think. Are there any more of these I want to do? I want to do number 7. Number 7 is which one of these things is true? And I think these questions are pretty tough because you have to know what all of them are asking. So f is a continuous function on the closed interval from a to b. Which thing must be true? Notice the conditions it's giving us. It's a continuous function on a closed interval. So we need to think, what do we know about things that are continuous? Is there a number c between a and b such that f of c equals 0? This is saying the y value is 0 somewhere. Well, no, that doesn't have to be true. In fact, I can come up with an example, a counterexample, really easily in my head where, okay, was the y value ever 0 there? No. It's a continuous function, but the y value never had to reach 0. And we don't have any theorems that say the y value has to reach 0 somewhere. Next thing says there's a c value such that the y value at c is between the y value at a and the y value at b. That is close to true, but it's not necessarily true. For instance, if there is a horizontal line, there won't be any y value that's above the ending y value, but above the beginning y value, but below the ending y value. So that doesn't need to be true. There is a number c such that f of c, the y value, is lower than all the other y values for all the x's in a and b. And this is true. In fact, this is the extreme value theorem from the first semester. It was the thing that we used to tell us that the candidates test had to be true. In a closed interval, when you have a continuous function, there must be a y value that is lower than all the other y values. There must be an absolute minimum value. It could either be at the endpoints or it might be at one of the critical values, but there's guaranteed to be a lowest value, a value that is lower than or equal to all the other values. Let's just see why the other ones aren't quite true. It says there's a number c such that f prime of c equals 0. Well, that's only true if f of a and f of b are true. That would be Rolle's theorem, but it doesn't say f of b equals f of a. This one says that the slope at c has to be equal to the average slope. Well, that sure looks like the mean value theorem. The problem is not all of the necessary components, conditions are there. It told us it was a continuous function, but remember that the mean value theorem also requires it to be differentiable. Otherwise, we could have a situation like this where there is no point where the slope is the average slope because there was a point where it wasn't differentiable. So that's what's going on in this. All right, hopefully that helps in your homework.